A common question I see on the forums is how to make a speedometer. So today I'm going to show you how very quickly to make one. Insomnia from UnrealTek.net, a division of BlenderTek.com. Remember our motto, create your way. For this tutorial, you'll need an image of your speedometer background and of the needle, and that's it. So let's get started. As you can see, I've made a speedometer tutorial folder, and in that we're going to right click, go to user interface, and then select widget blueprint to create a new widget. And we're gonna prefix it with a capital W and a underscore as is standard, and then I'm gonna call it speedometer. I have source control off, so I'm just gonna turn that off. Alrighty, so now all we need to do is get rid of the canvas panel if you want it to be placed in say like your widget main HUD, but in this instance I'll just assume that you want it as a separate widget you can place on the screen. So what we're going to do is we're going to add a border, and this will be our background. So this would be where you would put your speedometer image, so like the numbers or whatever, or a semicircle with dashed lines or whatever. So I'm going to then right click on border and wrap with, or sorry, I'm going to add a size box on top of the border, and in the border I'm going to hit size to content. Then in the size box, I'm going to click width override and height override, and I'll type in the size of my image, so whatever size your image is. So let's say my image was 128, let's go 256. Let's say my image was 256 by 256. I would set that, and that way it will stay that size. And we do have some padding, so we can set the padding to 0 if we want, and then it'll just fill up the border completely. So in the border, I'm going to set the anchor to the corner so that it scales properly with resolution. And just for visual purposes, I am going to make it a dark gray, almost black in the brush color. Now in the size box, I am going to add a vertical box, and in that vertical box I'm first going to add a border, and in this border I'm going to try to make a needle out of it, although I might need to create a canvas panel. Let's see here. Alright, well, what I can do to fake it is I'm going to add another size box to the vertical box. I'm going to put the border as a child of it, and then I should be able to set the border to fill in all directions, and the size box I should be able to do a width and height, a width of 32, a height of 128. No. Oh, there we go. That'll work. So I'm going to assume that should work. So then this border, if I was to rotate it, yeah, that'll work. Okay, so notice when we change the angle, it rotates, but it rotates on its center. So we need to change that, obviously, so that it rotates on the bottom, and this is where a lot of people get stuck. So to change this, you just need to change the pivot to wherever you think is right. So if you set it to 0, 0, for example, now when I rotate it, it's at the top corner. So in our case, we're going to have to go something like 1, 1. So now it's from the bottom right corner. So we need to come over a little bit on the X. So maybe like 0.9. This takes a little bit of tweaking. Let's go 0.75. That's close. Actually, it should be able to stick at 0.5. Yeah, right from the center because of this, because of the box. Perfect. But you'll have to play with the numbers. Usually about 0.1 0.1 and 0.5 is good for 0.1 on the X, and 0.5 is good for a regular image in an overlay box or in a canvas panel. So that looks like it's rotating pretty good. I want to rotate a little bit higher, so I'm going to do 0.9. And there we go. So now it's not rotating right from the bottom. I could even go 0.75, maybe give it more of that needle feel like that. Alrighty. So as you can see, a render angle of 0 gives us straight up. A render angle of -90 is going to give us straight left. So I'll be like 0 on your speedometer. And a render angle of 90 sets it pointing straight the other way. Now, you can obviously increase that value as much as you want. 180 gives you all the way that way. -180 gives you all the way this way. So if you're making a 360-degree speedometer, you have to remember that it starts at -90 and goes all the way to 180, and then you have to start working negative. So then I'd have to go -181, I believe. No. -179, and then you would have to go down from there and so on till you hit -90 again. So that's kind of the way it works, from 180 to -180. So it can involve a little bit of math if you want to do that, but we're just going to do a regular 90-degree or 180 degrees, a half circle. So from 90 to full. So if we wanted, even we could add a canvas panel to our canvas panel, and we could I'm gonna first of all set the border to 90. What we need to do is take the border or your image, whichever you used, or a border with an image as the brush, and name it needle. And we're going to need that to be a variable so that we can obviously adjust the angle. So I could just simply add some text in here. I could just say, let's say this is 120 if it was like a speedometer. You know, just pretending. Obviously this is not how I would go full out on it, but it works. And I could copy and paste that, move it over, and do 0, and then we just need to set the Z order to 1 so that they stay above. Oh, that didn't copy. Okay, well, I'm going to copy that and paste it. This one's going to be 120 and moved over. Okay, you guys are giving me problems today. Why is the 0 not showing up? Because it's in the corner, of course. Alrighty, good enough. Just for illustration purposes, obviously. So we can go back to our needle, and there you have it, from 0 to 120. So let's leave it back at its stock 0. Now I'm just going to save, compile, and save. Let's go to our graph and let's start the logic. So what we need are a couple functions, or a function at least. So I guess if we'd want speed text, we'd want a second function. So let's do that as well. Let's just add a text box. You could obviously put this wherever you want. And maybe I'll put it in the vertical box, and I'll add a primitive spacer before it with a Y value of 32. And then we could set this text block to something like 0 mph and center it. So let's go to our graph and let's create a function called getVelocity. Now, what we need to do is we first of all need to cast to whatever we're trying to get the speed of. So if it's car or whatever, you need to cast to that. So I'm gonna cast to character, third person character, since this is a third person template. Then I'm going to do object get player, actually get owning player pawn, since this is a character. So whatever pawn or character is owning this UI is getting casted into the third person character. So from the third person character, we're going to now drag off and type in get velocity. So this is just a standard node. It gives you the speed in centimeters a second that it is moving in X, Y, and Z. So to get that into a value we can use, we could simply just add up the X and Y value, but that could give you some inaccuracies when it comes to, say, drifting in a car. So what we would do is we could just use a vector length. And so what this does will return the length of the vector. So essentially it's going to give us this value times 1. So that converts it to a float. So we can create a local variable called velocity and make it a float, and then drag it in with Alt held down to make a setter. Connect up the return value to the pin like so, and then we need to add a return node. Add return node. And we want our return node to output a float called velocity. And since that's a local variable, I can't use that, so I'm just going to call it velocity out. And so we can just connect those together. Alrighty, perfect. So, a little bit more math we need to do. We could do this in 2 functions, but we can also do it in 1. I'm going to show you a little trick because of 4.9. So actually, this return node is going to be velocity, velocity normalized. And so we're going to set this variable to be called velocity norm. And then we're going to set that to that. And we're going to create another output that is just called velocity, and this will be for our speed output. So what we want to do is, I'm actually getting much ahead of myself. No, I'm not. So this velocity is actually the velocity, so let's just call that velocity. So, yeah, that's just the velocity, and connect it to velocity. Now, for the normalized velocity, it gets a little bit trickier. Not much, but just a little bit. And apparently my arrow keys are broken for some reason. It won't let me move that node with my arrow keys. That's very strange. Anyways, so what we need to do to get the normalized velocity is we need to take the velocity value. So I'm going to drag this back maybe. And what we need to do is a little bit of math. We need to divide float by float. We need to divide by 3500. And you might have to play with that value a little bit depending on your setup, but this is a good value I got. And then we need to clamp this. We want a minimum of 0 and a maximum of 1. So if we return that, that'll be the normalized velocity. So that gives us 0 to 1, depending on the velocity divided by 3500, because your velocity, say on a character, is going to be about 600 centimeters a second divided by 3500. You get 0.17. So you want to clamp, you want to make sure that's between 0 to 1. because let's say you had a velocity of 6,000, and well, that's very high, and it would make the speedometer basically bug out. So we have our get velocity function, and we could do that with multiple return nodes. In fact, we might, no, we will just create a second function. So what we need to do now is create a second function for our speed text. We'll call it get speed, and this is going to output a text called speed, and it will be measured in centimeters a second, or meters a second, I believe. Sorry. So we need to call our get velocity function, so just drag it in, and then we want to take out, that's weird, refresh nodes, compile. Let's just rename that, because that's kind of a weird bug I think I just found in the engine, maybe. Very unusual. Anyways, there we go. Okay, so drag and get velocity function in our get speed function. Then we want to take the regular velocity, and we need to divide a float by a float. We need to divide it by 100 to turn centimeters into meters, and convert that to text. Now if you wanted miles per hour, you would need to obviously do the conversion from, so type into Google how to convert centimeters to miles per hour, how to convert, you know, if you wanted kilometers per hour, how to convert meters per second to kilometers an hour. So then you could just do that math off of here and then just return it to a text value. So just like that. Let's see if this is good. We want grouping, half to even. Yep. I think that'll work. Let's compile that. Now lastly, in our event graph, very quickly, we just need to set up so that it's always changing. So first, let's set up event tick. So this is called every frame, because in 4.9 you can change the tick speed, but I don't think of widgets. No, it doesn't appear so. Anyway, so on the event tick, we want to first get our velocity. So drag in that function, and then we want to take the normalized velocity. I'm going to multiply it by 160. Again, you might have to play with some values depending on your usage. And then remember, because of that 180 thing, we need to subtract float minus float 180. Whoops. You subtract 180. So that's the first bit of math we need to do. Then we need to get game seconds, get game time in seconds. So that's basically how long the game has been running. We need to multiply that float by 27. This is another value you can play with, and then you need to get the sine of it in radians. The degrees, you'd have to do the conversion. And then we want to multiply float by 5. So we want to multiply the sine return by 5. And then we want to do a float plus float. And what we want to add is that result with this result. So now we're going to have two different settings. So let's create a branch by holding down B and clicking and connect it up. So now all we have to do is, that bugs me because that's not nice and clean. All we have to do is take this, and this is going to be our condition. If this value is greater than or equal to -30, if true, then we need to drag in our needle first. So drag in your needle with the control held down to do a get. drag off of it and type in set render angle. So we're basically changing that value that we saw in the designer. And so we want one from false, one from true. And then we obviously want needle hooked up to both of them. And then to finish it off, we just need to connect up the right ones. So this result gives us if it's true, and this result gives it if it's false. This one back here. Perfect. So lastly, we just need to go back to the designer, and we just need to bind this text. Bind. Oh, how come it's not seeing the functions? I made a function that returns text. Okay, well, what we're gonna have to do, because Unreal's being unusual, is take this text and create a binding, and let's just call this a get speed bind, because Unreal's being picky. And let's open up our get speed, and let's just copy our logic. Just copy those nodes and paste them back over in here. Unreal's being very picky for me lately. I think I've got engine problems. I need to reinstall it. And actually, so what we want to do is take this return value and let's do a format text. I'll show you a little trick. So this was just going to return a number, which is fine, but what we can do is we can format this. So if we type in format in curly brackets, type in speed and then give it a space and then say meters a second, or obviously whatever unit you were using. Now just connect the return value to speed, and so what that will do is it will replace the curly bracket speed with whatever we have plugged in there. So that's just a little trick for you. So that's bound. Now I believe that is the only binding we need. Yes, so let's give that a try. So it's compiled. So I'm gonna just go into the level blueprint to do this. Actually, I'm gonna go into the character, obviously. So character, where did I move him to? Change it around in all the engine versions. So what I'm gonna do is on event begin play, I'm going to create widget of class speedometer. Alright, so we have our speedometer widget, then we just need to take the return value, add to viewport, and let's see if it works off the bat. So we're going to hit play, we have our speedometer widget, and as you can see it turns the wrong way, but it is working, it is showing our speed. So it looks like it just needs to be inverted. So this is where you need to play with the math a little bit. It could be the angle is different than I needed. So in this case, you would do your get velocity function, and you could probably, no, sorry, in your event graph, you just need to play with these values a little bit. Subtract 90 minus 90. Alright, so it starts at 0, and I get up to 6. And then back down to 0. And so you can see when I jump I get a little bit faster, so just like so. And then if you want to turn the sensitivity down, I believe it's this value here, the multiplication. So if I multiply by say 50, compile, play. Nope, that makes it more. You need to make it bigger. So let's try 1600. Actually, that'll be much too far. But as you can see, that's like the sensitivity. So 160. What I got about halfway. Let's do like 350. Compile, play. Nope. Let's try 900. There you go, so you get the idea. And so the reason it twitches a little bit is that means your math isn't perfect, and it's also because of get game time in seconds isn't quite perfect. Obviously it's going to change a little bit from frame to frame. You can play with this math a little bit to try to change that. Like if I was to change the 27 to a 15, I'm going to change this back to 160 just because that's clean value. You can see it doesn't really do anything, but if I change it to a 1, you can see the game time seconds. Okay, it would have been better exemplified if I did set this back to like 1200. That's gonna change how it wobbles. So see, it's wobbling quite slowly. Multiply by 150. It's now wobbling extremely fast. So that's kind of how that works too. So that is about that. And then this value here, I believe, I can't remember exactly what it does. So that has an effect on it too. But those are just values that I found that worked well for a character or a car. You just need to do the math in your get velocity. Sorry, where do we convert it? Get speed. So to change it to whatever value you want. And that is about that. So anyways, I hope that helped. This went on much longer than I intended. So thanks again for watching from the team here at UnrealTek.net, division of BlenderTek.com. If you enjoyed this video and learned something, please like it. Don't forget to subscribe for more videos. We're on social media on the links on your screen. If you dislike this video for some reason, please tell us why so we can continually improve our videos based on your community input. We also take requests, so we'll see you next time. Remember, create your way.